YouTube, what is going on today? Welcome to another video, and in today's session we are going to solve some questions on logarithms. So if you don't understand anything, do well to leave your questions in the comment section below and I'll be sure to get back to you. Also, you can pause this video and try to do the questions by yourself and then come back to look at the answers that I'll provide. So let's get straight into the video. So we have the first question: log x to the power 4 minus log x to the power 3 is equal to log 5x minus log 2x, and we are supposed to find x. Let's find your x. So yeah, what are you going to do now? We are supposed to utilize the laws of logarithms, and according to the third law of logarithm, we know we can drop this 4 all the way to this side. So according to the power law, this is going to be 4 log x minus 3 log x is equal to, and then we can use the multiplication law in this place. So the multiplication law, we are going to separate this log 5 plus log x minus, and we're going to put all this in the bracket because the minus affects everything. We're also going to use the multiplication law in this sense, but the minus affects these two, so we are going to put it in the bracket, and then log 2 plus log x. Then we're going to go ahead and rewrite this: log x minus 3 log x is equal to log 5 plus log x minus log 2. We are opening this bracket, we want to expand it, so we multiply this by this and multiply this by this as well. So log minus log 2 minus log x. And then what we can do now is to represent every log x that we see over here with a variable like k. I prefer to use k. We can represent every log x that we see over here with k, so it can become a lot simpler to solve. You can go ahead and solve it with log x, but it's going to be a bit complicated because we are seeing a lot of log x's and we don't know exactly what to do. So we can represent the log x with a k and then come back to substitute it when we get the result for k. So substituting log x is equal to k. So wherever we see log x, we put k. So 4k minus 3k is equal to log 5 plus log x. So we are going to put k minus log 2 minus k. Let us simplify now. So we have log minus k plus k. So this cancels out. And then what are we going to left with? We also have here 4k minus 3k. So it's going to be k is equal to log 5 minus log 2 minus log 2. And then k is going to be equal to, we punch this into our calculator real quick, log 5 minus log 2. And then we get k to be equal to 0.3979. And then we know that k is equal to log x. So log x is therefore equal to 0.3979. And then we can use the conversion. We can convert this into an exponential form. And what is it going to be? If you don't know about this conversion, you can watch my video on logarithms. I explained this thoroughly, so you can check out the description for the link. So yeah, let us convert this. And if there is no base over here, meaning it's straight away to the base of 10. If there is no base over here, it's to the base of 10. So we're going to first write the main value, which is x, doing a conversion into an initial form. X is equal to, then write the base, which is 10 in this case, 10, and then write the exponent, which is 0.3979 in this case, 0.3979. So x is going to be equal to, we punch this into a calculator real quick, and then we get a result to be 2.5 or 5/2. So our x is equal to 5/2. Now let us solve the next question, and this is similar to question 1. So we are going to utilize the laws of logarithm over here to simplify this and find t. So the first one is going to be log 2 plus log t to the power 3 according to the multiplication law of logarithms, and minus log t is equal to log 16 plus log t. Then we're going to utilize the power rule over here and bring this all the way to the front to get log 2 plus 3 log t minus log t is equal to log 16 plus log t. And like I did in the first one, we are going to substitute every t we see over here with a variable. In my case, I'm going to use k. So substituting k with log t, or the other way around, substituting log t with k. And everywhere we see log t, we put k. So log 2 plus 3k minus log t, which is also k, is equal to log 16 plus k. So let us simplify over here. We know 3k minus k is 2k. So we're going to have 2k over here. But we know we can take this all the way to this side and make it negative when you're simplifying and grouping. So we take this all the way to this side, other side of the equation, and it becomes negative. So we have over here log 16 minus log 2 plus k. And then we're going to do the same and take this k all the way to this side and make it negative. So if it crosses the other side, if it's positive, it becomes negative. And if it crosses the other side, if it's negative, it becomes positive. So we're going to have over here 2k minus k is equal to, then we're going to punch log 16 minus log 2 into a calculator, and then it gives us 0.90308. Then we get over here, we simplify further, we get k is equal to 0.90308. But we know that k is equal to log t. So everywhere we see log t, we represent k with log t. So log t is equal to now 0.90308. And then we are going to convert this into an exponential form. So you're going to have t is equal to base 10. We still have a base of 10 over here because there's nothing. And then 0.90308. We punch this into a calculator, and then we get 8 to be our final answer. So t is equal to 8. All right, let us solve question 3 now. We are supposed to find b. So according to the power rule, we are going to drop this 2 all the way to this side to multiply the whole thing over here. So it's going to be 2 times 2 log b minus 3 log b is equal to, and we're going to use the multiplication rule over here to split these two. So we are going to make it log 8 plus log b, and then minus, because this minus affects the whole thing over here. So we're going to put this into a bracket, log 4 plus log b. Now we are going to simplify. So 2 times 2 log b is going to be 4 log b minus 3 log b is equal to log 8 plus log b. Then we expand this bracket over here. So this minus affects each and every one of these terms. So minus log 4 minus log b. So let's go ahead and represent every log b we see over here with a variable. That makes it a lot more clear for us to see. So substituting log b with k. So the first one is going to be 4k minus 3k is equal to log 8 plus k minus log 4 minus k. So we can see over here we have plus k minus k, they cancel out obviously. We are left with, we simplify this also, so we get k to be equal to log 8 minus log 4. And then we punch this into a calculator. So log 8 minus log 4 gives us k is equal to 0.30102. And then we know that k is equal to log b. So therefore, log b is also equal to 0.30102. So we're going to convert this now into exponential form. We're going to have b to be equal to 10 raised to the power 0.3012102. And then if you punch this into a calculator, we are going to be given the result of 2. So b is equal to 2. All right, let's solve the next question. Question 4 is going to be a bit different from question 1, 2, and 3. This time we are supposed to simplify these terms that we have over here into a single term. And what do we have to do now? The first thing you're supposed to look at are these terms. What do they have in common? What is the common factor? So the common factor that we have, the simplest common factor that we have is 3. So we are supposed to figure out how many times we can multiply 3 by itself to get 27, how many times you have to multiply 3 by itself to get 9, and how many times you have to multiply 3 by itself to get 81. And in this case, 3 times 3 times 3 is 27. So you have to multiply 3 by itself 3 times to get 27. So we are going to write over here log 3 to the power 3, because you have to multiply 3 by itself 3 times to get 27. We're going to do the same for 9. How many times you have to multiply 3 by itself to get 9? 3 times 3, which is 9. So we're going to write over here minus log 3 raised to the power 2, because you have to multiply 3 by itself 2 times to get 9. We're going to do the same for 81. How many times you have to multiply 3 by itself to get 81? It's 3 times 3 times 3 times 3 is equal to 81. So we have to multiply 3 by itself 4 times to get 81. So we then put it over here plus log 3 raised to the power 4, because you have to multiply 3 by itself 4 times to get 81. Now let's further simplify. So this over here, we are going to start using the laws of logarithm in the reverse order. So before it was multiplication, and we had to separate them by adding them, or division, and you have to separate them by subtracting them. By this time, they are having they all have like a subtraction or addition form over here, and we have to convert it into an addition, a multiplication or a division form. So what do we have over here? Let's take a look at these first two terms. We have a subtraction sign, so it's going to be log 3 raised to the power 3 divided by 3 raised to the power 2. And then we're going to just leave this for now, 3 raised to the power 4. Now let us take care of this over here. Let's simplify this. According to the laws of indices, if terms are dividing each other with a common base, which is 3 in this case, we subtract the exponent to write one base and then subtract the exponent. If you don't know about this, you can check out my indices course. I'll link it in the description. So we have over here log 3 and then 3 minus 2, because according to the law of indices, we have to subtract. Then we rewrite this log 3 to the power 4. So we have over here now log 3 to the power of 1, but we don't write it. Log 3 to the power 4. Now let us simplify further. Now we have over here an addition sign, and according to the laws of logarithm, if the logs are multiplying each other, we add them. But this time we are making it in a reverse order. So since there's a multiplication over here, since there's an addition over here, it's going to be a multiplication in this sense. So we are going to have log 3 times 3 raised to the power 4. So this is going to be our answer for now. But according to the laws of indices, we can further simplify this. Laws of indices, if you are multiplying indices or terms and the bases are the same, in this case, which is 3, we write one of the bases and then we add the exponents. So we are going to have log 3, here's 1. We don't write it, but let me just write it for now. And then we add them. So we're going to add the exponent. So we're going to have 1 plus 4 in this case. So our answer now is going to be log 3 to the power 5. But we can further use the power law to bring this down here to make it a bit more simple. So log 5 log 3, that is our final answer. So the simplified version of this over here is 5 log 3. All right, let's take a look at question 5. And question 5 is going to be similar to question 4. And what you're supposed to do over here, again, is to simplify these terms. And what do you have to do? We have to take a look at these terms over here, 64, 32, and 128, and find out what their common factor is, their simplest common factor. And in this case, their simplest common factor is 2. So you're going to find out how many times you can multiply 2 by itself to get 64, how many times you can multiply 2 by itself to get 32, and how many times you can multiply 2 by itself to get 128. And in this case, 2 multiplies itself 6 times to get 64, so log 2 to the power 6 plus log 2 to the power 5, because 2 multiplies itself 5 times to get 32, and then you're going to have log 2 raised to the power 7, because 2 multiplies itself 7 times to get 128. So let's further simplify this. So we're going to use the laws of logarithms over here, because we have a multiplication and a subtraction. So we are going to use the laws of logarithm. So we write log 2 to the power 6 times 2 to the power 5, because we have a multiplication addition symbol over here. So these terms will multiply each other. Okay, so let's go on. We're going to just leave this for now. Log 2 raised to the power 7, just to make things a bit clear. So according to the laws of indices, if terms are multiplying each other and they have the same base, which in this case is 2, we write one of the bases and then we add the exponent. So this is going to result to log 2 raised to the power 6 plus 5. And I'm going to rewrite this log 2 raised to the power 7. And then if we simplify this further, we get 2 raised to the power 11 minus log 2 raised to the power 7. And according to the laws of indices again, if we are having terms which are dividing each other, okay, let's just, do the logarithm side first. According to the laws of logarithm, we have a minus sign over here, so we can divide the terms. There's a reverse law. So log 2 to the power 11 divided by 2 to the power 7. And now we can utilize the indices law over here. So this is going to result to 2 raised to the power 11 minus 7. And according to the laws of indices, like I said, if they are multiplying, if terms are dividing each other, you write one of the bases. If the bases are the same, you write one of the bases, and then you subtract the exponent. So we are subtracting the exponent over here. So our answer is going to be log 2 raised to the power 4 in this case. So we can also further simplify this by dropping this over here according to the power law, or you can leave your answer like this if you want, but I just want to make it like this to make it a lot nicer, I suppose. So this is our final answer. So the simplified version of this over here, this term here, is 4 log 2. So our answer is 4 log 2. Yeah, let us solve the last type of this question. Question 6 is going to be like question 4 and 5. And you can pause this video right now and try to do it by yourself. I'm going to give you 2 seconds to pause the video and try to do it by yourself before I go into the answers. All right, let's go on to the answers now. So like question 4 and 5, we are going to look at these terms to figure out what their simplest common factor is. And in this case, is 2. So what do we have to do now? We have to find out how many times 2 can multiply itself to get 8, how many times 2 multiplies itself to get 4, and how many times 2 multiplies itself to get 32. And in this case, it's going to be simplified 2 raised to the power 3, because 2 multiplies itself 3 times to get 8, and minus log 2 raised to the power 2, because 2 multiplies itself 2 times to get 4, and you're going to have plus log 2 raised to the power 5, because 2 multiplies itself 5 times to get 32. Now, let us further simplify this. So we have log 2 raised to the power, okay, we can just further go on and just do it straight away. So we have over here the minus, we have the minus rule over here. So the division law of logarithms. So we're going to further simplify this to be log 2 raised to the power 3 divided by 2 raised to the power 2. I'm going to rewrite this 2 raised to the power 5. So we're going to use the laws of indices to further simplify this like we did in question 4 and 5. We're going to have over here 2 raised to the power 3 minus 2 plus log 2 raised to the power 5. You can write the answer straight away, but I just wanted to, show the process over here. So we're going to have 2 raised to the power log 2 plus log 2 raised to the power 5. And then we're going to use the law of logarithm, the addition law of logarithm, or the multiplication law to further simplify this. So it's going to be 2 times 2 raised to the power 5. And then we're going to use the law of indices to further simplify this to 2 raised to the power 1 plus 5. So you can write the answer straight away, but I just wanted to do it because of I want to make it a bit clear. So our final answer is going to be then log 2 raised to the power 6. And you can further drop this using the power rule to get a result of 6 log 2. So our answer is 6 log 2. Did you get the same answer? Question 7. We have a different type of question over here, and we are supposed to evaluate this logarithmic expression without using the calculator. And how do we do this? We can just go ahead and utilize the laws of logarithms as well as the laws of indices to make this possible. So let's get straight into the solution. All right, so let's take a look at these terms carefully. What do we have over here? We have a subtraction sign, meaning we can utilize the law or the division law of indices over here. But first, we need to make this a bit simpler for ourselves by using the power law, reverse power law, and bringing all this to the top. So let's do this now. We are going to have log 16 to the power 1 over 2 minus log 8 to the power 1 over 3 all over log 4. Now, since I have done this, it becomes a lot simpler to utilize the law of the division law of logarithms. So what do we do over here? We have a subtraction sign, so meaning we can rewrite this as log 16 1 over 2 divided by 8 1 over 3. That's 8 to the power 1 over 3 all over log 4. So we can go further and simplify this by changing all these to a common base of 2. We can change the 16 to a common base of 2. And how do we do that? We know that 2 times 2 times 2 times 2 becomes 16. So 2 multiplies itself 4 times to get 16. So therefore, we can rewrite this 16. We can rewrite the 16 over here as 2 raised to the power 4. So let's do that now. Log 2 raised to the power 4 is the same as 16. Puts all this in bracket and 1 over 2. And then divided by 2 raised to the power 3, because 3 multiplies itself 3 times to get 2 multiplies itself 3 times to get 8. So we can rewrite 8 as 2 raised to the power 3, and we also put in a bracket 1 over 3 all over log 4. Let's write this over here. So now to solve this further, we are going to use the laws of indices to further simplify this. So according to the power law of indices, if you don't know about this law, you can check out my indices video. I'll link it in the description below. So yeah, we can further divide this, solve this by 2 cancelling here, 2 goes into here 2, 3 here 1, 3 here 1. So this can be rewritten as log 2 raised to the power 2 all over 2. And we're going to have over here all over log 4. Now, let's further simplify this. So according to the division law of indices, we can further simplify this over here to log 2, because 2 minus 1, they have the same base. We multiply and we subtract the exponent. So log 2 over log 4. And log 4 can be written as 2 raised to the power 2, because you can multiply 2 by itself 2 times to get 4. So log 2 becomes 2 raised to log 4 becomes 2 raised to the power 2. Now, how do we solve this without inputting it into the calculator? We can utilize the power law over here and put this all the way down, so we get log 2 all over 2 log 2. And now we can see over here clearly we have log 2, so they can cancel themselves out, and then our final result will be 1 over 2. So our answer for this question without using the calculator is 1 over 2. So this is the evaluation. Let's take a look at the similar question. We also have to evaluate this term without using the calculator. So the first thing we have to do now is to check to see if you can get a common factor with all these terms, and the common factor is obviously 3. So we're going to rewrite this as log 3 raised to the power 2, because you have to multiply 2 by itself, 3 by itself 2 times to get 9. And we have over here log 3 plus log, let's just write this straight away, log, how many times you have to multiply 3 by itself to get 81? 4 times, so 3 raised to the power 4. But you ask yourself, this 1 over 2 can be used or can be brought to this side according to the power law of indices, power law of logarithms. So we can put it into a bracket now and write 1 over 2 all over 2 log 3. So in this case, we can use the law of indices to further simplify this. So 2 goes here 1, 2 multiplies this or goes into this 2 times. So we can rewrite this equation now, or this term now, as 3 raised to the power 2 log 3 raised to the power 2 minus log 3 plus log 3 raised to the power 2 all over 2 log 3. Now let's further simplify this by using the division and multiplication laws of logarithms. Over here we can see we have a plus, we have a minus, so therefore we can use these laws. So let's take a look at these ones first. Let's take a look at these 2 terms. Let's forget this for now. So according to division law of logarithms, if you have terms that are dividing each other, we can then subtract them, make them as different terms and subtract them. So we make a reverse this time around. So we go log 3 raised to the power 2 divided by 3 over here. So you're dealing with this term, and then we can rewrite this log 3 raised to the power 2 all over 2 log 3. Okay, let's further simplify this also. We can use the law of indices over here to subtract this exponent and get 3. So our result is going to be 3 plus log 3 raised to the power 2 all over 2 log 3. And now we can use the multiplication law of logarithm to further simplify this into log 3 times 3 raised to the power 2 all over 2 log 3. And according to the laws of indices, when the terms are multiplying each other and they have the same base, we write one of the terms and then add the exponent. So we get over here log 3 raised to the power 1 plus 2, and this will be 3. So we just write it straight away. 3 all over 2 log 3. And like you did in the first question, we can take this all over to this side according to the power law and get log 3 log 3 divided by 2 log 3. We just have to make sure these terms are the same so we can cancel them out. And of course, they're same now, so we can cancel them out. And our result is going to be 3 over 2. So we evaluated this term over here without using the calculator, and we got 3 over 2. So the last one is going to be homework, and I dare you to evaluate this expression without using the calculator. Very important. Do not use the calculator. So we have log 25 minus log 125 plus 1 over 2 log 625 all over 3 log 5. Evaluate that in the calculator and then put your answers in the comment section below. I'll be looking forward to your right answers. Thanks a lot for watching, and if you like the video, don't forget to leave a like on it and subscribe to this channel for more videos like this. And of course, if you don't understand anything, feel free to leave your comment in the comment section below and I'll be sure to get back to you. Till next time, Black, and I'm out.